Okay, so this video will be a worked example of how to calculate the Wilcoxon T test. If you haven't already seen my Spearman's video already, please do go back and make sure you watch that before this one, as that one explains things like tied ranks in a lot more detail than I will in this one. Okay, so here I've got a set of results where the researcher was looking for the difference in likability between a more frequently seen face and a least frequently seen face, rated on a scale of 0 to 6. There are 4 steps to the Wilcoxon test, so putting scores into a table, calculate the differences, rank the differences, and calculate the smallest sum of the ranks. Like with Spearman's, the most tricky step of the Wilcoxon calculation is step 3, which is rank the differences. Okay, so starting with step 1, you want to draw up a table that looks like this. So you've got participant number, the 2 different conditions, and the score for each participant, difference column and a rank column. Like with all sort of longer calculations, if you see my other videos or in lessons, you know that I like to do them in a table. Particularly for Wilcoxon, I think it works best in a table format. Okay, so just transfer all of those values from the results table into our calculation table. Step 2 is calculating differences. So for each participant, we want to work out the difference between both of their scores. So all you need to do for each participant is their first score minus the second score. So for participant 1, 5 minus 2 gives you a difference of 3. Go ahead and do the same for all of the other participants. Pause the video now to go ahead and do that. Okay, so these are the difference values that you should have ended up with. So again, you can just quickly pause the video to double check that you've got the correct values. The next step will become important later on, and all I do is just highlight each participant row in one colour if they got a positive difference. So participant 1 got a difference of +3. Was a positive number, so they're all in pink. So all the positives are in pink, and I put all the negatives in blue. And then I've left participant 3 in white because they got exactly the same score in both conditions, and so we consider them as a sort of nil difference participant. And we don't include those in our calculation of n for number of participants. Same as we did for participants who got nil differences in the sign test. Okay, so step 3, like I said, is probably the trickiest part of this calculation. I'm not going to go through it in too much detail, particularly in relation to what a tied rank is. So I'll just link the Spearman's video here in case you want to go back and watch that first. So what we need to do is rank all of the difference values in order from smallest to highest. And when we do that for Wilcoxon, we ignore whether it's a positive or negative number. So I've just drawn up a little table to help me do that. So I'll just transfer all the differences without the signs if they're negative and put them in order from smallest to largest. So we've got 1, 2, 3, 4, 5 1s, 2 2s, and 4 3s. We then need to give them a rank value, so 1 to 11, and then we do have tied ranks, so we need to give all of the 1s a tied rank, all of the 2s a tied rank, and all of the 3s a tied rank. So we do this by working out an average. So the 1s all the 1s take up the rank values of 1, 2, 3, 4, and 5. So we average those numbers, which gives us 3. And then the same for 6 and 7 gives an average of 6.5. 8, 9, 10, 11 gives an average of 9.5. Then what we need to do is transfer these final rank values into our calculation table. So again, I tend to start and sort of go in order, so do all the 1s together, all the 2s together, all the 3s together. Cool. Okay, so I'll just give you the opportunity to pause the video if you just want to make any checks on those values. The final step is fairly straightforward, and this is where my sort of color coding comes in useful. We need to calculate the smallest sum of the ranks. So what that means is you need to work out a total rank for all of the positive differences, so all of the pink final rank values, and work out a total, and then do the same for the negative differences. So all of the blue final rank values, work out a total and add them up. Pause the video now whilst you do this. Okay, so here you can just see I've written out the calculation, so added up all the positive differences, which gives a sum rank of 47.5, and the negative differences gives us a sum rank of 18.5. The final calculated value of Wilcoxon T is the smallest of these two sum totals. Therefore, T for the dataset we were working on is 18.5. I'm not going to go through how to interpret significance because either in lesson or during remote learning you guys have had quite a lot of practice at this.